Greetings, everyone. Welcome to Datagaps webinar. I am Raj Mohan, Associate Product Manager at Datagaps, and I would like to thank you all for joining us today. Now, topic of today's webinar is Migrate with Confidence, Data Trust, and Accuracy in Digital Transformation. Now, joining us on the panel today, we have Anand Rao, Vice President of Marketing at Datagaps, and Shubhanshu Dikshit, Senior Solution Architect at Datagaps. Now, with that, I will be turning it over to Anand and Shubhanshu. The stage is all yours.
Thanks, Raj. Hello, everyone. Thank you for joining us today. Today, we are discussing how organizations can handle application migration and data warehouse migration with greater trust and accuracy. These projects are often, as you know, high stakes because even small errors can affect the reporting, the operations, and the business decisions. So the challenge is not just moving data or applications, it is making sure that everything still works as expected after the move. So in this session, we'll talk through a practical way to validate the data, the transformations, the dashboards, and the performance before the go live so that teams can lower their risk, avoid surprises, and move forward with much greater confidence. So this is the agenda for today's session. It's organized into 4 parts. First, we'll look at the main risk indicators, the common migration challenges, and why migration testing matters so much in the application migration and the data warehouse migration projects. Next, we'll walk through Datagaps capabilities and a few success stories to show how organizations reduce risk, improve the trust in their data. And then Subhanshu here will have a live demo so that you can see how the Datagaps platform works in practice for these kind of use cases. And finally, we'll close with a practical checklist, key conclusions, and next steps that you can use for your own migration planning and validation process. So migration testing matters because moving data or applications without validation can create reporting errors, broken workflows, or performance issues and business risk after the go live. So let's start with a sobering reality. Data migration is no longer a back office IT task. It's a mission critical business risk. According to Gartner, a staggering 83% of data migration projects fail or significantly exceed their budgets and their timelines. So this isn't just an efficiency problem, it's a massive financial liability. So when a migration goes wrong, the clock starts ticking at an average cost of $5,600 per minute of downtime. So if a cutover window overruns by just 1 hour, you're looking at over $330,000 in lost productivity and revenue. So furthermore, migration-related security gaps contribute to data breaches at that now average $4.45 million per breach incident. So as we approach global data volumes of over 200 zettabytes, the traditional method of manual sampling is essentially obsolete. And sampling assumes that errors occur randomly, but our research shows that migration errors are almost systemic in nature. So if a transformation rule breaks, it doesn't just break one record, it breaks every record with that attribute. And if only a small sample, say 5% of your data is going to be tested, you statistically are likely to miss 100% of your systemic errors. So to mitigate all this, we must pivot to automated high fidelity validation. So let's talk a little bit about that. So why migrations fail, right? This slide catalogs the 6 most common categories of migration failure. So when we look at all the postmortems across enterprise projects, these 6 patterns appear repeatedly. And the important thing to stress here is that they're not independent. They compound each other. The first is system compatibility and semantic drift. This is particularly insidious because the failure is silent often. A field called, say, grand total in the source system may migrate technically cleanly, but the target system interprets it differently, and that error only surfaces weeks later when a business analyst notices that the reports don't balance. There's an expensive discovery to make after the cutover happens. The second is data integrity failures and the sprawl associated with the data volume, and they are often connected. So terms that have cleaned the ROT data, which is basically the redundant, obsolete, and trivial data, end up migrating far more than necessary, which increases the surface area for errors, inflates the timelines by 40 to 60%. Then comes the security and compliance, especially in regulated industries, and these need to be paid particular attention. So you have GDPR, HIPAA, SOX, all imposing these audit requirements that extend through migration events. So losing these audit logs during the transfer is not just a technical inconvenience, it can constitute a reporting compliance failure. And then there's always the performance regression, and that is often a surprise that hits at the go live of the migration project. So legacy systems that have been tuned over multiple years suddenly run on infrastructure that behaves completely differently. And without production-like load testing, teams often discover that the performance mismatches, and they encounter this the hard way. So the antidote for all these 6 is structured phased validation, which we'll cover in the next slide. So this slide highlights a common real-world use case where you're validating the migrated pipelines as well as the business intelligence dashboards during a source to target migration initiative. So this could be part of an application migration or a cloud migration initiative. So on the left, we see a variety of data sources that can be involved, including on-premise storage, cloud platforms, relational databases, flat files, APIs. And on the right, you see business intelligence tools like Tableau and Power BI. So this diversity makes validation complex, especially during large-scale migrations like the one from legacy systems to, say, a Databricks or a Snowflake, or from a legacy CRM system to Salesforce. And in the middle, we follow the journey of the data through the standard ETL process, moving from the source to the data warehouse and ultimately powering those analytics dashboards. So this flow happens in both the legacy as well as the target environments. So to ensure accuracy across this migration, Datagaps provides essential tools, and we will walk through those tools and what role each of those tools that I've highlighted here, ETL Validator and BI Validator, play. So the end result of such a use case is not just trusted data and analytics, but also trusted development process, giving business users and the developers confidence that their insights are based on accurate, validated, and migrated data. So This is like a testing life cycle, and it is a phase testing life cycle which follows a disciplined migration program. Now, the key message here is testing is, not a phase you enter after the migration is done, but it is woven into every stage from day one. At the pre-migration stage is where you establish the source baseline. So this means profiling the data quality, inventory dependencies, testing the connectivity, and building a dry run environment. And teams that skip this phase are effectively migrating blindly. They have no baseline to reconcile against. And then the second phase is cleansing from all the data profiling that you're doing. So you cannot migrate your way out of dirty data. If the source has corrupted records, duplicates, or orphan keys, the target will inherit those problems. So fixing those before the transfer is always cheaper than fixing them after. The third is process testing, is where your ETL scripts, your transformation rules, and any other mapping logic gets challenged against real data behavior. So you monitor the error rates and throughput continuously, and any degradation signals maps to problems early. And then the fourth is the post-migration validation, where people have seen it as the traditional testing phase. But by this point, you want no surprises. The record counts, the checksums, the business process tests should confirm that all your earlier gates have already predicted. And finally, you have the user acceptance testing and the other parallel testing that, which runs to build your confidence. So running the legacy system and the new system simultaneously, comparing the outputs, letting the business users sign off is the final human layer before you cut over. So this whole shift left principle is the most important design principle in the entire framework. So large-scale migration evidence shows that pre-migration screening, catching issues early before the cutover window is even open, reduces a lot of the reversion in the migration. So now that we know the problem, let's look at a few capabilities and then we'll go into the demo. For those of you who are joining us for the first time, at Datagaps, we focus on observing and validating the full data journey from ingestion to consumption in your analytics platform. So our mission is to empower enterprises such as yours with trustworthy data, analytics, and AI. So we deliver this through the DataOps suite, which is an end-to-end web-based platform that can be licensed as individual modules or as a bundle. And the core products for this use case are ETL Validator, BI Validator, and DQ Monitor, and as well as Test Data Manager, TDM, which together automate the pipeline testing, the report to data reconciliation, continuous data quality monitoring, as well as synthetic data generation. So you can deploy this suite on premises or in your cloud, fully contained behind your firewall. We never retain any of your data. We are built on the Spark platform, so we can scale to billions of rows, so you can validate at production volume without any kind of sampling. And Datagaps is recognized by the analyst firm Gartner as a specialist in the data pipeline test automation category. And we also have credibility in BI testing, as 2 of the top 5 Tableau installs rely on Datagaps for their BI testing. We are SOC 2 compliant and certified, and we have been in business over 10 years and serve over 75 customers. So that's a little bit about us. And as we think about all the reconciliation that happens, this slide kind of covers all the depth behind the gates. So there are two main areas. First is the layered reconciliation strategy that you see on the left. And this layer is primarily three pieces. You start with the structural checks, the row counts by partition, the schema compatibility, and the null rate bounds. They are fast, they're cheap to run. And then you move on to the content checks. And here the content includes the checksums, the hashes per partition, and other kind of field comparisons, as well as rule-based checks on the type, the range, the allowed values. And then third, you come to the business reconciliation, where the aggregates are aligned to the actual business meaning, like total revenue by period or active customer counts. And this is where the business stakeholders actually care about. And it is the layer that most automated tooling miss completely. And the reason you run these in this order is basically efficiency. So structural failures are cheap to diagnose and usually have obvious root causes, but the content failures require more investigation, and then the business reconciliation failures are more expensive to diagnose because they often require domain knowledge to interpret whether it was a revenue discrepancy caused by a rounding rule, a mapping error, a time zone conversion. And so rounding the lower, thinking of running the lower layers first means you fix the structural problems before they compound and kind of confuse your business layer analysis. On the right side, you have a number of ways. You have a deterministic masking is non-negotiable for referential integrity in test environments. You have role-based access control and encryption, and these need to be treated as test cases and not assumed. And then you have the whole DAMA, alignment to ensure you have the lineage chain regulators will ask you for post-migration. And so, as I've said briefly, we have different capabilities, and any kind of automated testing tool, we need to have the capabilities to make it operational. And so each row over here represents a quality gate, a formal checkpoint that must be satisfied with evidence before the project can progress to the next phase. And every gate over here has a specific Datagaps capability mapped to it, and evidence, a concrete artifact that constitutes the pass condition for that gate. So the phase one establishes, as I said, your source baseline. So the first gate proves you can connect and that your inventory is complete. The second gate captures the quality fingerprint of your data before anything moves. And this becomes your ground truth for all the subsequent reconciliation that you have to do. The second phase gates address the mapping contract. So the first gate uses metadata compare to surface any structural mismatches between the source and the target before the data flows. The second gate builds your rules library, the business logic that defines what correct means for your specific domain, including the generative AI-assisted SQL rule authoring. And then the third phase is where most teams underinvest. So running a single mock migration is not enough. The gates over here require repeated runs with full automated reconciliation each time, and all the evidence for each run, such as the logs, the remediation tickets, the rerun proof, is what these regulators and auditors want to see, and also the stakeholders, right? And the fourth phase extends the validation to the application layer, including the pixel level BI report comparison, and also treats any kind of security controls as testable assertions rather than assumptions. And the last phase finally closes the loop. It is something that you do a final rerun before the cutover, and you continuously monitor after that. So this slide is shows the business case for automating ETL testing, data migration, and transformation validation. And this is an ROI calculator that compares manual testing with automated approach using a tool such as Datagaps ETL Validator. And we start with a realistic project. So you have 300 tables, 4 test cases per table, 12 test runs across the entire life cycle in a year. And the test case creation is assumed to take the same path in both models, but execution is where the difference becomes clear. And the manual execution takes half an hour per test case, while the automation cuts it just to 6 minutes. And that creates a major time difference. So manual testing requires 8,400 hours, and while the automation brings that, as you see on the right side, to 2,640 hours. So from a cost standpoint, manual testing comes to around $420,000 in labor, while automation, including the labor, the license of the software, the training costs, the setup, the infrastructure, and any kind of variable runtime cost only costs $187,000. So the result is huge cost savings, a 55% cost savings, and a 69% reduction in testing time. So these are combined to deliver a 4x ROI on your investment just in the first year. So the message is simple here. Automation does not just save effort, it also lowers the project cost, speeds up the delivery, makes large-scale migration projects and testing programs much more efficient and predictable. So now I'll hand it over to Subhanshu for a demo that showcases all that we bring to bear in these kind of projects. Subhanshu, over to you.
Thank you. All right. So welcome to the demo section of today's discussion. Before I do some live test cases, I will be talking about where exactly the application fits in within your process, within your project, and from a technical perspective. So we'll be spending a bit of time on theory before seeing the actual product work. Let's discuss the first aspect, which is where exactly do we come in terms of phases of a migration project. Now, the migration project that you're dealing with can be very different than the one you see on your screen, but it's very likely that it's going to follow a similar trajectory. On the top, you have the specifications of a migration project. You get a requirement, you get an understanding, architects decide what the target sector is going to be it an on-prem system or a SQL to non-SQL transfer. The requirements vary and thus the actual need for migration. But once the requirements are set, you start with the preparation phase, then you do the actual migration, and then you have a system in production, which you do a good amount of QA into before, say, removing the parallel system in action. And that's something that we see quite commonly across a lot of migration projects, which is that people keep parallel systems running for a while, at least a few months or years in some scenarios, to ensure that everything is in sync. And when we understand the severity of these reasons that we are working with financial data, we're working with, say, medical data, it's very important that these pipelines stay working even after migration. So that's a lot on why exactly we need this. Let's discuss the actual process and where exactly we come in. The very first step that we see in a lot of migration projects within preparation is understanding the data. So that implies that looking into your existing legacy system and applying a good amount of profiling to firstly understand the data, and then a good amount of data quality to basically be assured that the data is adhering or respecting its expected business logic. Simple examples here is just ensuring that if you have, say, foreign key rules between systems, like a particular foreign key is a primary key association in another table, is it really true? Are these, the data sets even connected? Are there a lot of orphan records present within the system? There's a lot of different variety of such rules which can be present. And this is not even considering business rules, where the values that are received by, say, the end user or by your legacy system, are these values making sense even from the context of, say, a business use case? For example, if you're looking at a percentage column and that percentage column is at 1000, well, numerically things seem fine, but not via a percentage, right? So the first aspect is profile the data, understand the exact problem statements within the data, and potentially fix it as well. So that's one place where we are going to discuss the usage of the application. And then comes the very first aspect, which is source extraction. So the main kind of system here is that we will be moving a good chunk of objects, nearly all the data in its entirety, from a legacy system to another, say, landing zone or to a starting point for the migration to begin. So, for example, you might be doing ECC migration from S4HANA to ECC, or you might be doing an Oracle system migration, or you might be doing something a bit more traditional in terms of, say, non-SQL to SQL DB. This initial shift of data from, say, the legacy system into a source landing zone itself is lossy, because you will be using importing and exporting systems, and you will be moving a lot of files potentially. Any transfer of data is lossy in nature. So here we need to ensure that every object has been accounted for, and within every object, every element should also be accounted for. And what I mean by this is that if there are exporting or importing issues, for example, address lines have been trimmed up, or for example, there are certain batches which have not made it through to the other side of the migration, all of these have to be caught at an element level, not just at an object level, but at an element level. The application allows us to create test cases and also call out these differences, because we perform 100% validation in our data compare nodes. So we have the source data ready, but we are not simply using it within our modern application. We are potentially applying a good amount of transformation. This is what we call as not a lift and shift migration. You see, there's a lot of migrations that you do which can be considered lift and shift, where you're just moving a database and that's more or less it. But in more cases than not, when you are, say, moving an entire database, architects have a tendency to change or add a few more derived columns into the mix. And so if you are changing an entire application, I reckon there's going to be a lot more transformational changes present. So using the corresponding quality rules and profiling, we can firstly gauge what transformations have to be updated. So we have a good understanding of if a transformation will even make sense thanks to our profiling. And once these transformations have been applied, we need to do two types of checks. Firstly, we need to ensure that from a black box perspective, the transformations make sense. A very simple example to kind of make a lot of sense of this is that, say, you created a new flag, a couple of new flags. Now, of course, we're going to check if the flags are correct. That's in the data compare. But just to ensure that the flags are of the correct category. For example, you might be using Y or N, true or false, 1 or 0. A simple rule to ensure that the flags are in the correct, say, definition across all these additive flags which have been created is a simple check. And that's something that the application offers. And to come back to the important use case, which is ensuring that the flags have been correctly defined, that's another place where the application has the capabilities of ingesting mapping documents and creating the transformation validation for you. So we take the source data, we look at the documentation, we create queries of the supposed transformation, and then we compare it with the actual developed transform data. And so we call out the issues here as well. An easy example would be in terms of, say, a particular developer has decided to add a round function, but the documentation states that we need a floor function. So floor and round are very kind of close by in terms of what they do, but they have a distinct, say, output when it comes to values above 0.5. So, well, the application will catch these problem statements, catch exactly where they are placed in, and will alert the end user on the same right. And all the other aspects that we have discussed of data quality can be applied to the transform data as well, ensuring that this is also working with regards to the expected logic. Finally, once we have this transform data ready, we start to move the application into production. So this is the phase where we do a lot of SIT, UAT testing, ensuring that the applications are working as expected. Here, there's a couple of important caveats. Firstly, we need to ensure that the modern application is referencing the appropriate data set with the appropriate logic. It's the exact same use case of transformation, but because these applications combine multiple tables, ensuring that the numbers in the application match the numbers in a transform data set is also something that the application does. Apart from this, ensuring that from a UI UX perspective, the new application is well working as, or in a similar fashion as the old application is very important. A super simplified use case here is that if you're, say, shifting your application from one BI tool to another, then ensuring that the same filters are applicable, that the numbers are identical, also to ensure that the performance of the reports is along the same lines, the application can create test cases along all of those systems. And of course, once we're in production, we can also discuss production monitoring, which is another important use case that comes by in a migration project, which is not just the migration itself, but what happens after the migration. Throughout this entire system, we will be doing automatic test case generation and automatic reporting, but more of that can be found in the next slide. So here now we're looking at a more data-centric purview of this use case, and we see exactly what we are trying to look into. When we start a migration project, there's a high chance that we're going to have parallel systems. So here you can have storage to Snowflake, or it can be Databricks, Postgres, AWS, any particular system works as the target. And so when you're moving from one stage to another, so you'll see that the very first thing we're going to offer is automatic test case generation for data migration validation. This is basically in such a fashion that you can just drag and drop tables, and the application will create test cases for you. And most importantly, you do not have to worry about scalability. The application scales automatically without the end user performing any input. And then even if you're working with billions of records and 1,000-column wide tables, you should be good to go because every element will be accounted for. Then once again, we come to the ETL part. This is the transformational equivalent from the previous slide. Once again, automatic test case generation is something that's very helpful in the scenario, especially because the counterpart would be a manual user going in and recreating the logic manually. So that's a lot of time wasted. Instead, mapping documents can be ingested to automate this process thoroughly. And the final part is from a BI perspective, where we need to ensure that the numbers between the BI reports are identical. We need to ensure that the visuals between the reports work in the exact same manner and look the same, even if you're changing BI tools for that matter. And of course, filters, slicers, security, performance should also be working in the exact same capacity. Because regardless of what happens in the backend, for the front end, the user should have the same experience, and that cannot be compromised on. So that's more or less what I wanted to cover from the tech perspective. Let's actually showcase the product. So let's get started with a couple of live demos. All right. So the very first thing I want to get into is a bit on the hardware architecture, because again, a very important question that anyone watching this might have is that, are you guys a SaaS? I can assume that's within the chat questions as well, as I spotted it earlier. So I'd like to use this time and elaborate a bit more on this. Well, while we do have a SaaS capacity, most of our clients prefer our application be installed within their infrastructure behind their firewalls. And that's the principle that we have designed our product with. So we do have a SaaS offering that we can look into, but as you can imagine, most clients prefer the application within their infra. And with regards to the sources that we would like to discuss, we're talking migration. What do we mean? Well, in migration, you have a lot of backend systems, and our application can connect to a ton of them. What you see on your screen is the kind of default set of sources we come with. If there are something additional in terms of, say, CRM tools or other systems you would like to connect to, do note, we have CData connectors, generic connections, as well as API connections within our system. So let's kind of go through the entire process from an end result perspective. So I've already opened a few test cases to kind of get into the groove of things. The very first thing you will notice within our application is that we work with a lot of data quality profiling and rule systems. So again, this incoming data is supposedly the data in your legacy system. And firstly, what you would want to do is you'd want to apply a profile on this data. So what I've done in this profile system, well, I've just applied a good understanding of what the overall data set is supposedly about. This includes what the volumes that we are dealing with are. This includes the null percentages, the distinct percentages, min-max values, averages, as well as the patterns seen. For example, in this use case, I see transaction type is S, W, and for some of them, P is a value that comes up. Now, from a business perspective, P should be a value that should be absent in this data set. So I know there are some bad records purely because this is an incorrect transaction type. I can understand the overall distribution. I can even understand what the format of the data I'm dealing with is inherently. And I can use all of this information firstly to create rules for the system inherently. Now, of course, the application can use generative AI. And when I talk about generative AI, once again, we are not connecting to an outside service. We are connecting to the existing LLM endpoint within your infrastructure itself. So, for example, if you're working in Azure AI Foundry, which is owned by your infra team, and your AI team will be the application's endpoint connection. Nothing will ever be sent out. So you can use that to generate the rules, or you can use the zero code, low code data quality rule-based system, which is as easy as defining what your rule is. For example, transaction type should be within my transaction type domains, or my reference order pattern should be a 5-digit number. Now, again, I'm skipping a lot of a variety of rule sets, but I would like to say that there's a lot of different dimensions that we cover. But that's the very first aspect, understanding what the data is and making sure that the data adheres to its expected logic. If it does not, the very first thing we're going to do is that we're going to segregate the good and bad records into different data sets, telling you exactly what subset of your data is bad, even before the migration starts. So this is a very important thing, so that we are not migrating the wrong data inherently. Apart from that, what we also do is that we provide a proper association, a score at a rule level, which is basically the ratio of the good records upon total records. And we provide this aggregation at a rule level. We score it up to a table level. And this is something that goes all the way up to a system level. So here we have a data quality score about 83% across multiple models, across multiple dimensions. And as you can imagine, there's a lot more nuance in this in terms of understanding which tables, which models, which columns are causing the most amount of problems within our system. So that's the very first thing. We ensure that before even the transformation, we understand the data and we fix the data before the migration begins. All right, so now let's go into the migration part. When we do a migration, what happens? Let's take a look at the first half of this particular table. Here we have a source object and a target object. In the source object, I've just picked up a subset of my DIM customer table. I can pick up the entire object as well, but I can pick up the subsequent object as well. So I have either picked up the entire object or say a temporary set of it. And then I'm comparing it against my target, which is in Snowflake. My source, by the way, in this example is SQL Server. But once again, all the sources you have seen at the start of this demo, all of them are valid for this use case. What I do with them is that I run a data compare. So here, the application inherently takes care of data type mismatches, column name mismatches, column order mismatches. All of this is handled inherently in smart ways, using fuzzy logic or using AI in certain scenarios, but mostly using fuzzy logic. So the application is going to take care of all the hassle that you have to do if you're ever doing this manually, including data type conversions. And what it provides you as an end result is a proper distinction of what are the records which are mismatched, on which columns these mismatches lie, and if there are records which are present only in the source system, which didn't really make it into the target system, and vice versa. So this is our very first use case, which is where we are trying to understand what the exact transfer of data resulted in. Were there any issues at any point? And this exact use case, right, between source to target table, this can be created in bulk. That's a very important use case within our application, where all you have to do is go into the generate function right here and just drag and drop the tables, and the application does the rest for you. So again, that is something that we don't really have a lot of time to showcase, but in a demo, I'm more than happy to showcase it in a deep fashion. But for now, let's discuss the next part of our slides. So if you remember earlier, we are transforming our data. So it's not just apples to apples comparison. So the first one is very straightforward, an apples to apples comparison. I have the same dimensional object. Maybe the column order is different, and maybe the flags and table formats are slightly different, but it's essentially the same table. However, there could be a lot more issues between them. Now, in our example, we have some transformations in the mix, right? What do I do with them? Well, here in this example, you will see that I can automatically generate the transformed logic. In this example, you'll see me use my generative AI function to basically talk to my system and, hey, this is the derived column that has been added. Please make it with the tables that I've provided you. The application does that. It's very context aware, and it never hallucinates because we have a proper RAG associated with it. And because of this, we can basically create a transformation logic in line as part of the test case generation itself. And when I compare this against the actual transformation, I see that, all right, the values seem to be matching. But there are some values which are unaccounted for. There are some orders without any of the corresponding. So there's transformation checks. And similar to the generate function here, we want to automate this. So if you have mapping documents, we have entire subsections called mapping manager, which are built to basically ingest your Excel files, regardless of the format they are in, and then use that to, again, generate the transformational checks, the ones that you just saw right now, or the ones that you saw before them, which were data quality checks. So a good chunk of your entire process has been automated, where all you have to do is just oversee and maybe fix a couple of aspects if you want to. So that's a bit more on the overall side of data, and there's a good amount of automation inlaid here. Apart from this, there's another aspect which is in terms of the BI layer. Now, in this example, the first 3 nodes is something that we've already covered, except here you will see that we're connecting to the underlying DAX models. Now, again, this is a Power BI centric example, but the same principles apply for OBRE, OAC, or for Tableau, or for Cognos, or for QuickSight, and a slew of other BI tools as well. But the basic gist here is the very first comparison is with the actual data. This is just a data model being compared, and we see that there are some issues present within this particular system. Do note the market here. We see a lot of issues, but I see that Europe is common across all of these issues. All right. So before and after a migration, the data model might seem to have a few issues. The next thing we do is that we connect to the BI report directly to the UI element, to the application directly, and we extract the information from there. BI tools are natively supported, but through API, we can connect to modern tools as well quite easily. So we extract the numbers here after we apply filters and slicers. All of these are part of the steps that the application gets into inherently. The one I've highlighted is a important one there. And then we extract the information as numbers. And then we can do the same thing between, in this case, it's dev and prod, but you can consider this exact same use case between on-prem and cloud, or before and after migration. And so here we're comparing the systems from a visual perspective, from a data perspective at least, ensuring that the numbers seen in your end applications are in fact comparable. If they are not, we see that, yes, the Europe market seems to have some problems and the values are not really matching. The final one is, let's skew the data. Let's get the actual snapshot of the report and compare both of them. Before and after a migration, are the reports looking identical? Are they in sync? The application handles these as well. Now, in this example, I'm going with the Power BI use case, but do note that we have also been used for, say, Tableau to this particular use case, BI migration validation, is also something I want to give a quick shout out to. But for now, you see everything that's highlighted in pink. It's technically an issue, something that's unexpected. And we do the exact same thing for a pixel-to-pixel comparison, as Anand alluded to earlier, where we're going to keep track of alignment changes, visual changes, and everything in between, color changes, font changes, and so on. So anything that's technically a mismatch is being highlighted. And it's very helpful from an end user perspective because I can see exactly which report has which problems, and I can go in to fix them inherently. If I was working between Tableau and Power BI, I would have used the generative AI function here because it would have used the visual LLM to basically really the AI handle most of this, and the AI will just summarize everything and send it back to me. Speaking of that, let's actually finish this demo up with the final stage, which is archiving, ticketing, and pipelines. Basically, how we sum everything up together and show it to the end user. Well, firstly, you'll see at a test case level itself, I have a lot of specific options. I have options to automatically send out notifications. I have options to automatically process the bad data. This is very important because finding out problems is only one part of the solution. It's kind of in the entire scenario. You now have to fix the problem, so to speak. That is why we ensure that post-validation processes can also be performed. Another thing would be the reusability of test cases across environments as well as across different projects. Now, depending on the project, I'll get into a lot more specific details into this, but this is an important aspect, which is reusability of the test cases. And the last part is, of course, how do we deal with reporting? So there's a lot of different options that you have. every test case is inherently going to create its very own specific report. And depending on the phase of the project, you might want a data quality report, the one that looks like this, where we check the overall schema, we check the overall DQ sheet, we understand the system at an overall level. So perhaps you'd want to go for a customized scenario. Or perhaps you're in the migration validation stage. And at this point, you would like to know at a, say, report level, what are the tables which are incorrectly matched and so on. So, you can be in a situation like this, where at an individual test case level, you would like to know which test cases have which specific problems. So for example, we had created 6 test cases in parallel right there. And I can go into, say, DIM department and understand exactly what was the issue with DIM department. Now here I see there were records present only in the source which were absent in the target. So that's why this is incorrect. And my reporting section can be as complex as being, say, report-centric, meaning your BI report-centric. What I mean by this is you can have reports and multiple test cases associated with these reports. And what the end user will see is at a report level, what are the test cases which are causing problems? And because we can chain our test cases one after the other, so you can basically have Tableau reports being compared against the data warehouse, which is in turn being compared against the file, which is in turn being run against DQ checks. You see there's an entire chain of checks we can do. The application allows you to take that into account as well inherently. So there's a lot that we can do. And one final aspect that I'll say before we shut things off is that the application has a ton of integration with external tools. While you would want to schedule this, and as you might want to do with your parallel or existing systems, the application has a lot of native integrations and schedulers and support. But if you want us to support, say, your existing CI/CD tool, or maybe your DevOps tool, like, say, Jenkins or Azure DevOps, or maybe GitHub Actions or a tool set like that, do note that we have a ton of these integrations in a bi-directional fashion. So we'll be able to send information back and forth using the ton of, say, extensible tools that the application provides inherently. So with that, I would like to stop the demo now, and let's move on back to questions. So I'll just bring up that particular slide in. So let's see if there are any specific questions. And yeah, we're back on camera as well.
Yeah. So maybe, Subhanshu, we will postpone the questions to the end. I have a couple of slides, and then we'll take the questions. So, okay. So again, how do we measure the migration readiness, and how do we ensure that the migration is a go or a no-go, and it serves the KPIs are present here, and they have 2 distinct purposes in the migration program, and it's important not to confuse them. The first purpose is to prove your cutover readiness, demonstrating to stakeholders and governance bodies that the migration meets the agreed quality bar. And the second purpose is measuring whether your test process is actually working, finding issues early in the mock cycles rather than discovering them later in production. So here are some KPIs. So validating coverage or validation coverage answers the question of how much of your entire migration surface area do we actually have our eyes on. So teams often discover that they have detailed rules for the high-profile tables, but no automated checks on dozens of other secondary tables that quietly carry all the critical reference data. So there are coverage gaps here, which you'll be surprised later by. And then you have the defect discovery rate and the defect leakage rate. They work together. So you want a high discovery rate in early mock cycles, and that means your testing is finding the problems. They are cheap to fix. And you want a 0 or a near 0 defect leakage rate at the cutover time, meaning the issues are caught in the testing, not in production. And if your leakage rate is still high, your pre-cutover testing has not been rigorous enough. And then you got other KPIs like the reconciliation pass rate. And this will be your primary go or no-go signal. And the bar at the bottom of the slide lists the specific thresholds that you have to have 100% partition count matching for the critical tables. All foreign key and orphan checks are passing, and there's parity in the KPIs with agreed tolerances, and the BI validation that Subhanshu just showed is confirmed. And so these are not like aspirational. This is the minimum bar. And then you got other KPIs like time to detect or time to fix, are all these process health metrics. It takes days to diagnose a failed check. And now your observability and lineage tools need investment if it does. So for any kind of change data capture based migrations, you have a lag monitoring, which is a live signal. A growing lag means that your incremental synchronization is falling behind and needs intervention before the cutover happens. So these are some of the KPIs. Next slide. And so we wanted to give you a key conclusion and next steps. So to close the message or the overall presentation, the migration trust is something that is built through a phased, repeatable validation. The strongest programs validate early. They reconcile the data in layers and require evidence in every gate that happens. The next step is to baseline your critical data, the mappings, the KPIs, and then run at least 2 full mock migrations with automated reconciliation. You define the clear go and no-go thresholds for the counts, the hashes, the business KPIs, the BI parity, and the performance before doing the cutover. And if your team is short on time, start with the minimum viable rigor workflow. So you baseline, you validate the mappings, you run the mock migrations, you reconcile in layers, and you test the end-to-end performance and enforce like a formal cutover gate and monitor closely after the go live in the production environment. So this is how you reduce surprises, you protect the business trust, and move from risky migrations to a completely engineered outcome. So we can request a demo over here, and now we'll open it up for questions. So Ramohan.
All right. Thank you, Anand, and thank you, Subhanshu, for a very insightful session and a practical walkthrough for the product. Now we'll move on to the Q&A section. So yeah, for the first question we have, what does a real go or no go decision look like in this kind of project?
Yeah, so let me take that question. So again, as I summarized, this kind of decision should be based on the evidence. In many projects, people say they are ready because the deadline is coming up and not because the results are strong. So a better approach is to define the clear success rules, the key data checks that are passed, the major KPIs that are agreed upon within the limits, the dashboards behave correctly, and the performance is acceptable under realistic conditions in your organization. And teams need to run like full practice cycles before the cutover and not just isolated tests. So that way, a go live decision becomes a business decision supported by proof and not a leap of faith. So you want this to be as disciplined as possible so that the project is ready for production. So,
all right, moving on to the next question. Can we reuse the test cases created post-migration?
Yep, let me take this one. Yes, the answer is short. The application can reuse test cases, and it's a common motif that a lot of clients use the tool for creating the initial pre-migration DQ rules and post-migration comparison checks. And they use the same across multiple dev cycles as well as in production monitoring scenarios. So reusability is a prime use case within the product.
Thank you, Subhanshu. Now, moving on to the next question, which is, can we use the BI part of migration validation, or do I have to get the entire product?
Yep. So, you can decide only on what you want. The way we price our product is we have separate pricing for the data part and separate pricing for the BI part. So if you're looking at only across BI migration use case, then that is something that you can opt into. And if you're looking for an end-to-end use case, you can do both the products.
All right. Moving on. How is Datagaps different from scripts or point tools?
Sure. So the very first place where this application comes in is that it's a full-fledged enterprise application. So it takes care of a lot of hassles that you don't have to really from scripts. If you're working with scripts, there's one singular person who knows those scripts more often than not. But more importantly, scripts are heavily technical, require a great amount of expertise and in very niche understandings to execute correctly as well as to maintain. And UI-based drag and drop, simple to execute test suite is something what most enterprises teams prefer. That way, reusability of the same resources can be used across different projects and across different systems. And most importantly, a great amount of dependency can be easily reduced from that. With regards to the technical requirements that are with regards to the technical distinctions that the tool has from scripts, well, the first one, most obvious one, is going to be on scalability, because the application can easily work with billions of records and 1,000-column wide tables effortlessly. And more importantly, the application is also going to take care of automatic test case generation. When you're creating scripts, you have to create them and you have to maintain them. When you're using the application, you just have to point exactly at which objects you want to create this particular set of test cases, and the application takes care of all the rest. So these are a few ways in which the application is very different from scripts or point tools.
Right. So I would like to add to that. So, the value that Datagaps brings is all this can be in one platform. It supports pipeline validation, BI testing, monitoring, and even test data support. And if you were to do it separately, you would have to create custom scripts for each of these areas. And so then you'll have to maintain them, as Subhanshu mentioned. And so it's not a repeatable system. And so you want to reduce the dependence on these fragile one-off solutions.
Right. Since we are running out of the time, let us take the final two questions, shall we? All right. Yeah. One other question is, how do you work with Gen AI from a compliance perspective?
So I'll take that one. With regards to generative AI, the way we work is similar to the rest of the application. The entire application can be installed and deployed within your infrastructure. So the generative AI LLM endpoint that we'll be using is also going to be connected to your specific, say, infrastructure itself. For example, if you're in Azure, then we'll be connecting to Azure, OpenAI, or Azure AI Foundry. If you're in AWS, we might connect to SageMaker or Bedrock. And from a Google platform perspective, it can be, say, Gemini. So we'll be connecting to the endpoints within your infrastructure itself.
Now, for the final, do you want to?
Yeah, I think we are running out of time here. So Rajmohan, so I thought I'll step in and say thank you, everyone, for joining us today. Please reach out to us at contact@datagaps.com for any further information. Scan that QR code there for a 2-week free trial where you can test our product. Subhanshu will be there to help you out as well. So we look forward to hearing from you and taking the next step forward in your migration journey. Thank you.
Thank you.
Thank you.
For further questions, feel free to reach contact@datagaps.com. Request a free demo, scan the QR code below. Thank you.